The James Webb Space Telescope is messing everything up. This didn't happen by chance. The Hubble Space Telescope can distinguish objects that are multiple times dimmer than those recognized by the James Webb Telescope. A cooperation between the US, Canada, and Europe, driven by NASA, the James Webb Telescope has upset our perspective on the universe. Pictures of far-off systems since before time began and amazing scenes of nebulae, the dusty origination of stars, started pouring in very quickly after it started full tasks in July 2022. It's as intense, while perhaps not more so, than we expected. A year after the fact, JWST is still sending back gigantic measures of information to cosmologists on Earth, who are struck by its capability to alter our understanding of the universe. The most recent revelation settled on by JWST, anyway, throws decisions into question about all that we are familiar with how universes structure. What sort of earth-shattering revelation did the James Webb Space Telescope expose? We should find out. As per science, the universe started with an enormous detonation from the outset, an uproarious bang. The most broadly acknowledged speculation for how the universe started is the theory of the Big Bang. No, we're not talking about the TV show. As per the Big Bang hypothesis, the universe was made in excess of 13.8 billion years ago from a single unbelievably hot and thick point known as a singularity. It didn't take place in a space that was beforehand there. Rather, it began the cooling and development of space itself. It explains a part of what stargazers see with telescopes on the ground and in space. It explains why, as space continues to grow, different worlds are moving ceaselessly from us. It explains the weak glow that should be visible all throughout the universe. It's a shockingly viable and delightful record of the beginning of the detectable universe. To put it momentarily, as indicated by the hypothesis, hydrogen, helium, and lithium were first made. From that point, all heavier components were delivered in stars. Furthermore, supernovae, vast expansion, a continuation of the Big Bang, even makes sense of why the universe is so homogeneous, similarly made up, and how universes are scattered over space. Grandiose expansion sounds terrible, right? Anyway, it's not the very kind of expansion that you're envisioning. On the off chance that space had a huge development right off the bat in its presence, a ton of qualities of the universe as far as we might be concerned today make sense. As per the expansion hypothesis, the tremendous measures of energy present in space itself made the universe extend radically. A tiny part of a second after the Big Bang, the universe proceeded to extend and cool. After this time of expansion, albeit significantly more gradually, space was quickly extended by expansion, bringing about an exceptionally uniform surface. However, the universe isn't incredibly uniform during expansion. Minute varieties in density that existed in the early universe were incredibly enhanced. The universe's tremendous scale structure, including colossal sheets, air pockets, and world bunches, was at long last delivered by these density varieties. That is the beginning. What will occur at the point when the universe breaks down? It is indistinct from the theory of the universe's origin whether the universe will continue developing and cooling or whether it will ultimately implode into another very hot singularity, conceivably proceeding with the cycle. The qualities of two puzzling substances known as dark matter and dark energy will probably decide the inevitable result of the universe. If both are concentrated on further, it might turn out to be clear whether the universe will end in ice or fire. Earth, the remainder of the planetary group, stars, galaxies, and interstellar gas together make up around 1/16 of the universe's all-out mass. The effects of dark matter or the excess mass of the universe are apparent to researchers. High amounts of it make far-off light emphatically curve, and it causes galaxies to rotate faster than they would if by some stroke of good luck conventional matter were present. Yet, the nature of it is as yet unclear. Astronomers are investigating the past. At the point when they utilize a telescope in view of how long it has taken the light from the Andromeda Galaxy to reach Earth through space, they notice the Andromeda Galaxy, the nearest huge galaxy to our own, not as it is at the present time but as it was more than 2 million years ago. In both space and time, different galaxies are found a lot farther away. NASA's James Webb Telescope goes around 1 million miles from Earth to circle the Sun around a steady point. A tennis court-sized sunshield safeguards its colossal gold-covered primary mirror, which is basically as tall as a giraffe and gives unparalleled perspectives on the universe in infrared light. It took some time for the telescope to be assembled. It was initially expected to launch around 2007 at an expense of $1 billion. It was first imagined during the 1980s. When JWST was finally launched in December 2021, its supposed expense had ascended to nearly $10 billion. Anyway, its complexity caused extended delays, consuming cash to the point where it was once named the telescope that ate space science. There have been distressing moments even after the launch. It required a month for the telescope to make a trip to its expected area outside the Moon's orbit. Many complex components were needed to deploy all of its gear, including its gigantic sun shield that keeps the infrared-sensitive equipment cool. At a time when the universe was 25% as old as it is today, new photographs from the James Webb Space Telescope uncover, for the first time, galaxies with stellar bars, extended designs of stars running from the centers of galaxies onto their external circles. Astrophysicists must work on their models of galaxy development, considering the discovery of these purported primeval galaxies, which are indistinguishable from our Milky Way at such a youthful age. Before JWST, Hubble Space Telescope photographs had never tracked down bars at such youthful ages. One galaxy, EGS 23205, appears as a somewhat more than a plate-shaped blur in a Hubble view, but in the similar JWST picture from this past summer, it is viewed as a dazzling, twisting galaxy with an unmistakable star bar. Two barred galaxies older than any previously found were discovered by the research group. EGS 24268 is another primeval galaxy that dates to around 11 billion years ago. By coordinating gas into the central region of the galaxy, bars help star development and play a critical role in galaxy advancement. By coordinating the gas, bars additionally help in the formation of very large black holes in the centers of galaxies. In different ways, the discovery of bars during such early epochs disturbs speculations about galaxy development. This early bar discovery gives galaxy development models another way to approach using bars to accelerate the formation of new stars in early galaxies. Moreover, the sheer fact that these early bars exist puts theoretical models to the test since they rely upon precise universe physics to estimate the right number of bars. In the meantime, the James Webb Space Telescope has formally completed its first year of recording the quality of stars and the nativity of their cores. The Laniakea complex, which is the nearest place where stars are forming, was recently displayed in photos by NASA. Numerous specialists have previously taken pictures of this area. However, the James Webb Space Telescope has given us a new and in-depth perspective. The telescope's picture of the Laniakea cloud complex captures the moment of star formation with exceptional clarity. For the first time, the picture portrays a situation that looks like an intriguing, turbulent mass of gases ejecting from the formation of new stars. The gas is illuminated from all sides, giving off a beautiful ruby glow. This is similar to being present for the visible universe's most memorable moment of existence. Protoplanetary disks, which can be considered the building blocks of planets, are likewise visible in the picture from the James Webb Space Telescope. A protoplanetary disk is a spinning circle of gases and dust that surrounds a young star. With regard to stars, planets eventually form from these disks. One star, in particular, sticks out in the picture as a huge blue mass with the designation S1. It seems to push away surrounding gases, leaving a void region around it. It stands out from other stars that blend in with the background. As a result of this, the James Webb Space Telescope has had an exceptionally successful debut year, performing well above expectations. NASA claims that it has provided astronomers and researchers with extraordinary pictures and information to analyze. It has revised our understanding of the universe and made it possible for researchers to conduct exceptional remote region investigations. Astonishing pictures of our solar system's planets, including Jupiter, Uranus, Neptune, and Saturn, have been captured by the telescope. Moreover, the James Webb Space Telescope has enabled scientists to look further into the early history of the universe, where they made an unexpected discovery. The satellite observatory has already identified 6 massive galaxies that existed between 500 million and 700 million years after the Big Bang that created the universe. The discovery has completely altered what researchers currently believe about the origins of galaxies. No one anticipated that these galaxies would be this large. researchers expected to find only small infant galaxies at this early stage of the universe. Since this frequency is invisible to the naked eye and can detect the faint light produced by aging stars and galaxies, the telescope utilizes it to study the universe by looking into the far universe. The observatory can metaphorically travel back into the past to nearly 13.5 billion years ago. The finding that massive galaxy formation began very early in the universe's history has overturned what many of us had previously considered to be established science. So far, these objects, which we have tongue-in-cheek named universe breakers, have lived up to their name. Since galaxies must grow in size, the models will need to be altered. When we peer back far into the universe, the James Webb Space Telescope is pulling us further into the universe's past than ever before.